Okay, so Assalamu alaikum and good afternoon, everyone. Hope you people are doing well. Okay, and let us start with the session. Uh, First of all, we'll revise the thing what we have done yesterday. Okay, and then we'll move ahead. Okay, I think yesterday we started with the threads. Okay, we have seen the concept of the thread. Uh, it is on the Jamboard, I think so, because let me open the Jamboard first. Where is Jamboard? This is my Jamboard. So we started with the thread concept and we have seen the types of thread. Am I audible to all? Because I need to check whether I'm audible, visible properly or not. Okay, thank you so much. Okay, so yesterday we have started with the concept of the thread. Okay, even though this particular topic is in the last of this particular chapter, but still we have started in the in the middle. Okay, let me show you the syllabus first. That is important for you people to understand where we are running and where we are. Khan Shoaib Akhtar. ठीक है चलो होता है कभी कभी accidental cases. Okay, so let me show you the syllabus for this particular chapter. Just एक बार देख लो इसको. So this is the second chapter we have started. Then we started with the concept of a process. Then we have seen the process states also. These topics are not quite आगे पीछे, but you can just understand. Then we have seen the process description, the description of each and every of a process. Then we have seen the process element, okay, and those elements were present in the process control block. Okay, so this is PCB, that is process control block. And then we have seen the process states also. Like we have seen the new state, we have seen the ready, running, waiting, or sleeping, and then last one, dead state. Okay, so these were the different process states. Okay, so we have completed this 2.1 in the last to last session, and after that we started with the concept of. So we started with this 2.3. Okay. Hmm. So we started with this 2.3 yesterday, and we have completed the concept of thread. Then its definition, its type. Okay, let me show you. Okay, so we started with the concept of the thread. Then we have seen that this is the lightweight process, and we can also say that okay, this is the smallest unit of a process. Okay, this is the smallest unit of a process. Okay, so we can have single threaded process also. As you can see in the diagram, we can have single threaded process. It means that we have a single thread in a single process. Okay, in a process we have a single thread, and we can have a multiple threaded process also. Okay, so we may have multiple threads working in the same process. Okay, and obviously if I'm working under the organization, any XYZ organization, then whatever the task that organization is having, the same task I'll be assigned. Okay, so I'll be doing the same task my organization is doing. Okay, so in the same way, whatever your thread is doing, so the same work is of the process also. Okay, so the work which has been assigned to a particular process, so will be the task of the thread also, the thread of that particular process. Okay, because there may be ambiguity. Ambiguity may come like we are having for each and every process we may have number of threads working in the same process. Okay, so the care has to be taken. That's why the thread management is there, that we need to manage the threads of each and every process also. Okay, so I have mentioned over here that this is your process P1. Okay, and we have multiple threads in it. Okay, So sometime it can be shown like that also. Let me show you with the यहीं पर मैं इसको बना लेता हूँ. So इसको थोड़ा मैं रब कर लेता हूँ. Okay. I've shown the a symbol of the thread in this way, like a circle, small circle. You can have the symbol of the thread in this way also. Okay, so this is one thread, this is second, third, fourth, fifth, sixth. So these are the threads. Okay, so simple it is shown as a रस्सी. इसको हम लोग बोलते हैं उर्दू में, हिंदी में. So these are the threads. Okay, this is 1, 2, 3, 4, 5, 6. So all six threads belongs to the process number one. Okay, so thread one, T1, T2, T3, T4, T5, and T6. All threads belong to the process one. Okay. So in the same way, I can have another process that is P2. Okay, I can have another process P2, and I can have two or three threads working in it. Okay, so maybe so it has depend on the process that how many threads are there. Okay, so we don't have to care about it how many threads are there. Whatever number of threads are there, but all those threads belong to the same process only. Okay, so we have seen these the concept of the thread. This is the lightweight process, and this is the sub part. And we again, if we divide the task of each of the process, then we can say that we have multiple threads. Okay, so this is the smallest unit of a process. So in this way we can have multiple smallest units, so we can have multiple units of a process. That is the thread. Okay, then afterward we have seen, let us come to the slide now. Okay, so this is the thing which we have already seen. Okay, this is a type user level thread, that is which the thread which is being managed by the users only, and the kernel level thread which is managed by the operating system. Okay, now come to the two types of thread. These are the user level thread and kernel level thread. Okay, so this is the actual type user level thread. So user level thread basically works of the work of the thread managed. Sorry, management is done by the application itself. Okay, यानी कि basically जो हमारा application होता है, so that application is going to do all the tasks like work of a thread management. For example, we have, let me take one ball pen over here. So, for example, we have one process over here. We have one process, that is process P1. Okay, so that process P1 may have a number of threads like this thread, and this thread. So we have total three threads. Okay, so T1, T2, T3. So work of the thread management is done by the application itself. Application मतलब ये process. और for example ये process किसका है? For example ये जो process है वो है VLC player. Okay, this particular process belong to the VLC player. Okay, so it means that जो हमारा VLC program, VLC player, which this is an application program. This is an application program, and for this application program we have the process one. Okay, I say this is the process one, and for this particular process we have T1, T2, T3. Okay, so T1, and this is T2, and this is T3. Okay, now try to understand the hierarchy of this particular diagram, that we are having application program. I say this is my application program. Okay, application program. For this application program, when I start this particular application program, so this particular process will be created. Okay, so this is the level one. This is my level one. This is my level two. Okay, यहाँ पर हमारा process है, and at level 3 we have number of threads. Okay, that is, in this case we have T1, T2, and T3. Try to understand the hierarchy. Okay, so just for understanding this statement you need to learn this particular diagram. Okay, so work of the thread management. Okay, now so which task will be performed by T1, which task will be performed by T2, which task will be performed by T3. ये कौन करने वाला है? That is going to be performed by the application. Indirectly process करेगा मतलब VLC player आपका जो application program है वो करेगा. ठीक है? So the work of the thread management, who is going to execute first, who is going to execute next, who is going to execute last, that is going to be managed by the application. So which task? For example, we have divided the task into X task, Y task, and Z task. Okay, so which the X task will be performed by For example, T2. Okay, the Y task will be performed by T3, and Z task will be performed by T1. So that we have assigned. So that we have not done. That work is being managed by the application itself. Okay. I hope you people are understanding. Okay. कुछ नहीं आया तो समझ में नहीं आया तो पूछो बताओ we'll revise the things are like quite very simple. Just need to understand the basic concept, the basic foundation. Okay. Kernel is not aware of the existence of the thread. Okay, here kernel is not aware that these threads are being created, these threads are being managed. Okay, yeah, because I told you that we have two spaces, like we have kernel space, we have user space. Okay, so remember कि ये हमारा जो है ना तो यूजर स्पेस ये हमारा कर्नल स्पेस, ठीक है, और उसके बाद में फिर हमारे हार्डवेयर पार्ट शुरू होता है. तो ये आपका यूजर स्पेस होता है, ये आपका कर्नल स्पेस, दोनों का पार्ट अलग अलग है. But your kernel space, your kernel does not know the awareness, it does not aware that these particular threads are being managed. हम लोग रिमूव करते हैं, that is not required. Okay, आगे बढ़ते हैं. So the thread library contains, okay, we have a concept of a thread library. Okay, let me show you the diagram also. That diagram is important for you because thread library आपको तभी समझेगी जब आप डायग्राम देखेंगे. ठीक है, कौन सा डायग्राम आप लोग को बताओ मुझे. जो बुक में डायग्राम है वही मैं आप लोग को बताता हूँ. So for that purpose I need to rub this. ये तो ऑलरेडी रिकॉर्डिंग में आ गया ये वाला पार्ट. ठीक है, so I'll be removing this part now. Okay, so let me show you the diagram for this particular thread library and this user level thread. Okay, so user level thread simply I can show in this way. So ये मैंने एक line खींच दिया simply, and I have multiple threads working. So this is my one thread, this is my second thread, this is my third thread. Okay, so this is my user space. Remember, this is my US, that is user space. ओके, ये लाइन यहाँ तक खींच डाला. उसके बाद में ऑल थ्री थ्रेड्स आर बीइंग मैनेज्ड बाय द थ्रेड लाइब्रेरी. ठीक है, आपका थ्रेड लाइब्रेरी यहाँ पर बहुत इंपॉर्टेंट रोल प्ले करती है. सो वी हैव अ थ्रेड लाइब्रेरी व्हिच इज बीइंग मेंटेन्ड बाय ईच एंड एवरी प्रोसेस. ओके, which is being managed, which is being maintained by each and every process. And we know that in our process we have multiple threads. Okay, एक से ज्यादा thread होते हैं. So this is my thread 1, this is my thread 2, and this is my thread 3. Okay, so all threads are being managed by this thread library. Okay, so this is my thread library. Let me write it अच्छे से, thread library. ओके, अब ये थ्रेड लाइब्रेरी आ गई. उसके बाद में दिस लाइब्रेरी, अभी ये हमारा यूजर स्पेस था, ये हमारा कौन सा स्पेस है, कर्नल स्पेस है. तो ये मेरा है कर्नल स्पेस. यहाँ पर मेरा कर्नल स्पेस के अंदर यहाँ पर मेरे पास मेरा ये है सीपीयू. ठीक है, अब ये सीपीयू हमारा कनेक्टेड है इसको. ठीक है, सो ऑल दिस. अच्छा, अगर मैं बोलूँ हाइपोथेटिकली बोलूँ तो ये जो पूरा पार्ट है आपका यहाँ से यहाँ तक, ये पूरा क्या है आपका, ये आपका प्रोसेस है, ये आपका प्रोसेस है. ठीक है, तो ये जो प्रोसेस है बेसिकली, तो प्रोसेस के अंदर आपके तीन थ्रेड्स है, दैट इज T1, T2 एंड T3, व्हिच आर बीइंग मेंटेन्ड बाय द थ्रेड लाइब्रेरी. आपके थ्रेड लाइब्रेरी कंटेन्स, अब यहाँ पर देखो, योर थ्रेड लाइब्रेरी कंटेन्स कोड फॉर क्रिएटिंग एंड डिस्ट्रॉइंग द थ्रेड. So for T1, for T2, for T3, whichever threads are required, so for code for creating and destroying the threads. So your thread library has authority to create and destroy the threads. Okay, and for message passing and data between the threads. इस दोनों threads के बीच में कुछ message pass करना, that can be done with the help of this thread library. Obviously this is the, we can say the interface between the two threads. Okay, between any of the thread, this is the your thread library is the interface. Okay, so they can communicate, they can message pass, they can pass the message and they can pass the data between the threads with the help of the thread library. Okay, so thread library contains all the function. And for scheduling thread execution, तो आपको बताया मैंने कि कौन सा थ्रेड आपका पहले एग्जीक्यूट होगा, which thread is going to execute first and then next and then next and then next and so on. Okay, so that is also going to be managed by the थ्रेड लाइब्रेरी. सो थ्रेड लाइब्रेरी के अंदर एक तो क्रिएशन, देन डिस्ट्रॉइंग, देन मैसेज पासिंग, देन पासिंग मैसेजेस, देन पासिंग डेटा. डेटा यहाँ पर है जो आपको अगर दिख रहा होगा अच्छी बात. सो पासिंग मैसेजेस, पासिंग डेटा बिटवीन द थ्रेड्स, एंड हर एक को शेड्यूल करना फॉर एग्जीक्यूशन. ओके, so this is also a task of thread library, so that which thread will come for execution first, then second, then third, and so on. Okay, so these are the four functions which are being performed by the thread library. Okay, so this is the one new thing which is there in the user level thread. Okay, so ये सारा काम आपका एक्चुअली थ्रेड लाइब्रेरी करती है, लेकिन बोलने के लिए क्या होता है कि प्रोसेस ने किया, फिर उसके ऊपर बोलने के लिए क्या होता है कि भाई एप्लीकेशन ने किया. सो आई हैव ऑलरेडी टोल्ड यू द हियरार्की. पहले एप्लीकेशन प्रोग्राम, हमको तो यही लगता है ना कि एप्लीकेशन प्रोग्राम काम कर रहा है, बट एप्लीकेशन प्रोग्राम के पीछे आपका प्रोसेस काम कर रहा है, और उन प्रोसेस के पीछे आपके नंबर ऑफ थ्रेड्स हैं. ओके, जो कि इंडिविजुअली काम कर रहे हैं, इंडिविजुअल सेपरेट काम कर रहे हैं. ठीक है, बट लेकिन है तो प्रोसेस में, और उनको मैनेज करने के लिए हमारे पास में थ्रेड है. सो सी द हियरार्की एंड द डीपनेस इन दिस पर्टिकुलर यूजर लेवल थ्रेड एंड कर्नल लेवल. ओके, सो इतनी डीपली आपका ये काम होता है, and we are not aware that we just open the application, we just open VLC and do the task, whatever is required, so we do the task. We just don't aware that all these things are happening in the background. Okay, so this is about the user level thread. The next is I have mentioned one advantage. It does not require kernel mode privileges because it is present in the user space. So kernel mode का privileges को required नहीं है. Okay, they can proceed with the user space only. The next is it can run on any operating system. Obviously, जो system है जो manage हो रहा है, तो all these things are being done on each and every operating system. Okay, and faster to execute and manage. Okay, ये तो normally हर किसी advantage में होता है. ठीक है, so user level thread. Let me repeat the things. We have multiple threads which are running. And these multiple threads which are running in the process are being managed and maintained by the thread library. Okay, which is present in the user space. Okay, and it does not have, your kernel is not aware of the existence of the thread. Whatever number of threads you are creating, you are not creating those threads. Okay, your process is creating that thread. Okay, तो ये आपका प्रोसेस बना रहा है, और प्रोसेस थ्रेड लाइब्रेरी को बोल रहा है कि इन सबको मैनेज करो. तो वन एंड द सेम थिंग, सारा काम ऊपर, अगर ऊपर का शेल अगर देखेंगे, so your outer shell is your application program, the inner shell is your process, and the innermost shell is your thread. Okay, so you have multiple threads in the process. Okay, so ये आपका क्या बोलेंगे इसको, यूजर लेवल थ्रेड था. I think all the things are getting recorded, so I can erase all of this. Okay, going ahead. After user level thread, okay, see, I have not mentioned the diagram in the particular slide. Okay, so whatever I drawn in the recording, so that comes in this particular. ठीक, मैंने जो पिछले slide पे जो मैंने draw किया था, it has already been recorded now. Okay, so if you want to go through the diagram, if it is possible, then I will take the snap of the diagram, then I'll put in the slide, and then I'll share it with you people. So still, if you want to go through the actual diagram what I've shown you, so you can go through the recording also. Okay, so we have next type of the thread, that is kernel level thread. Okay, come to the second one, that is kernel level thread. Okay, I have few points actually with me. I have not created the slide in full manner. Still, चलो ऐसे देखते हैं. So here obviously your kernel level thread, obviously we have some first of all, try to understand what are the kernel level threads. Okay, obviously we have some application which are kernel level application. Like I told you that, okay, we have few services like network services, and we have other services which are not which are beyond the user level. Okay, user level expectation. So those services which are directly managed by the operating system, obviously they are higher level services. Okay, and user need not to start those services manually. जैसे मैंने आपको example दिया था, this is not like आपको every time you need to start the network services. Okay, whenever you start your computer, so network services get automatically started. Okay, and if your Wi-Fi is on, okay, so your laptop will automatically connect to the nearest Wi-Fi if it is already connected, if the password is already saved. Okay, so we don't have to connect each and every time, we don't have to start the service each and every time. Okay, so we have number of services which are there in the operating system, okay, which are directly managed by the operating system itself. Okay, so those are the kernel level application. Okay, those are being managed by the kernel level application. Okay, so for those applications, some process will be created. Let me show you with the help of the diagram. So we have some sort of application like we have network services, we have other services. Okay, so these are the kernel level application. Okay, we are not going to manage, we don't manage actually these particular applications. So these are some sort of application. Okay, so ये जो application, for example, take one example, this is the network service. Okay, so for this we must be having some sort of process also. ये जो आपका कुछ ना कुछ process होगा network का, तो ये आ गया process level पे. Okay, for this particular process हो सकता है यहाँ पर multiple threads काम कर रहे हैं, एक से ज्यादा बहुत सारे threads काम कर रहे हैं. ठीक है, and all the threads are the part of this particular process only. ठीक है, सारे के सारे किसके पार्ट है, आपके ये प्रोसेस के पार्ट है. So this is T1, T2, 3T, T3, T4, and T5. So all five threads are the part of this particular process, and this process belong to the network application, and this network application is a kernel level application. Okay, so in this way you can imagine. So obviously the thread which are in the all these threads are being managed by the kernel only, because या जब kernel level का जो kernel manage करेगा, the one and only very short thing, kernel threads are directly supported by operating system. Absolutely and obviously. ठीक है, तो kernel level threads are directly supported and managed by the operating system itself, because indirectly आपका उसमें operating system बोला है. But you can just take out the difference between the क्या बोला मैंने, kernel threads, these thread and this operating system. इन सबके बीच के अंदर कौन कौन है मालूम, ये आपके थ्रेड के बाद में इसका प्रोसेस है. ठीक है, देन प्रोसेस के बाद में उसका एप्लीकेशन है, और एप्लीकेशन के बाद में फिर आपका ये आपका डायरेक्टली कनेक्टेड है. अच्छा, ये डायरेक्टली भी नहीं कनेक्टेड है, बीच में कुछ ना कुछ सिस्टम कॉल लगेंगे. ठीक है, कुछ ना कुछ बीच में सिस्टम कॉल्स लगेंगे, एंड दो सिस्टम कॉल्स दी ऑपरेटिंग सिस्टम. तो इतना सारा जो बीच में कार्यक्रम है, इन सबको हाइड करके, इन सबको ट्रांसपेरेंट करके सीधा डायरेक्टली बोला है कि कर्नल थ्रेड्स आर डायरेक्टली सपोर्टेड बाय द ऑपरेटिंग सिस्टम. ओके, सो ये एक इतना पूरा हो सकता है बीच में, बट बोलने के लिए बोलते डायरेक्टली थ्रेड्स आर कर्नल थ्रेड्स. The name has to be mentioned. Kernel threads are directly supported by the operating system. Okay. So next point, kernel maintains context information for process as a whole and thread within the process. Very simple statement. Just try to understand. So your kernel is going to maintain the context information. Context information means all the related information. Just for our moti we just count it as a whole information. Every complete information about that particular process, like uska process ka state, then process ka ye uska program counter, each and everything comes under the context. ठीक है, तो उसके related जितनी भी information है, that all the information as a whole, process as a whole, because when we talk about the process, then आपका process as a whole माना जाएगा. And when we talk about that particular thread, so thread किसका है, basically process का है. So basically we have a process, and for that we have a multiple threads. Okay, so kernel maintain your kernel is going to maintain the context information for process as a whole, okay, and thread within the process. So इस particular process के अंदर कितने thread है, इन सब की separate information भी आपका kernel maintain करता है, इन सब की सेपरेट इंफॉर्मेशन भी आपका कर्नल मेंटेन करेगा, और प्रोसेस की एज अ होल ये भी इंफॉर्मेशन आपका कर्नल मेंटेन करेगा. ठीक है, सो कर्नल इज गोइंग टू मेंटेन द कंटेक्स्ट इंफॉर्मेशन फॉर प्रोसेस एज अ होल एंड थ्रेड विद इन द प्रोसेस. सो थ्रेड इज अ सेपरेट थ्रेड. ठीक है, तो ये सारे के सारे सेपरेट थ्रेड्स है, सबकी सेपरेट इंफॉर्मेशन भी स्टोर करेगा, अपने पास मेंटेन करेगा, और प्रोसेस एज अ होल यानी कि प्रोसेस की आईडी क्या है, प्रोसेस का स्टेट क्या है, फिर प्रोसेस के फिर अंदर और जो जो इन्फॉर्मेशन होती है उसकी अकाउंटिंग इन्फॉर्मेशन वगैरह वगैरह सारी इन्फॉर्मेशन कर्नल स्टोर कर रहा है। और थ्रेड की जो जो होती है, थ्रेड का कुछ हो सकता है यूनिक आईडी हो, बिकॉज वी डोंट हैव गॉन थ्रू दैट मच डीप इनसाइड द थ्रेड मैनेजमेंट। तो लेकिन उसको हो सकता है उसकी भी कुछ आईडी हो, उसकी भी कुछ पहचान हो। इवन दो दोज आइडेंटिटी इज volatile, जब तक आपका प्रोसेस है ऑब्वियसली वो इन्फॉर्मेशन भी रहेगी। सो ऑल दिस इन्फॉर्मेशन इज बीइंग मेंटेन बाय द kernel. Coming to the next one, that is kernel perform. Now see what are the different operation which is being performed by the kernel. Kernel perform thread creation. Obviously इसके जो threads है वो आपका kernel ही, जो kernel के thread है वो kernel create करेगा, जो user level के thread है वो user करेगा. That's very very common thing. Okay. Then kernel is going to schedule them also. Okay, because obviously if there is a kernel level thread, if there's a kernel level thread, then it cannot be scheduled by the user level or a thread library. आपकी thread library उसको उसको नहीं कर सकती. हाँ, अच्छा आपको अभी डायग्राम बताना है ना, तो डायग्राम बताऊंगा तो आपको और अच्छे से समझेगा वो चीज. ठीक है. अच्छा पहले मैं डायग्राम बनाता हूँ, उसके बाद मैं आपको एक क्वेश्चन करता हूँ. ठीक है. These are the multiple threads. Okay, मैं डायग्राम ही बना देता हूँ. Thread number 1, thread 2, thread 3 and thread 4. Okay, so 4 threads are there. This is my, अरे कैसा जा रहा है. So this is my okay, so this is my user space and this is my kernel space. यूजर स्पेस है मेरा और कर्नल स्पेस है. ओके. अब इस कर्नल स्पेस के अंदर मेरे पास में कर्नल लेवल थ्रेड्स भी यहाँ पर. ठीक है. जो सो दीज थ्रेड्स आर यूजुअली टर्म्ड एज द यूजर लेवल, जिसके अंदर कुछ नहीं है. ये हमारे कर्नल लेवल थ्रेड्स है. फॉर एग्जांपल ये कर्नल लेवल थ्रेड, कर्नल लेवल, इसको जिसको मैं सर्कल कर रहा हूँ, दीज आर दी कर्नल लेवल थ्रेड्स. ओके. अब ये आपके कनेक्टेड हैं, यहाँ पर कनेक्टेड हैं. ठीक है. ऑब्वियसली आपके देन यू हैव अ सीपीयू. If you remember the previous diagram, then you will easily understand that okay, something is missing. Something is missing. इस डायग्राम में कुछ तो मिसिंग है. This is the diagram for kernel level thread. This is the diagram for kernel level thread. If you remember the previous diagram, then you are missing something over here. Are you missing something? Please let me know. बताओ जल्दी बताओ. एक चीज है लाइब्रेरी. वेरी गुड अनस. द कंप्लीट नेम इज, yes, the complete name is thread library. Okay. In the user level thread, very good. In the user level thread, we were having one concept which was thread library. Okay. In the thread library, the thread library was responsible. In the user level thread, the thread library was responsible for the creation of for the creation of thread, for destroying of thread, for passing the messages between the thread, for passing the data between the threads, and for execution of all the threads, for scheduling all the threads for execution. टोटल कितने काम थे थ्रेड लाइब्रेरी के, रिपीट करो मेरे साथ में. फॉर क्रिएशन, फॉर डिस्ट्रॉइंग, फॉर पासिंग मैसेजेस एंड डेटा, फॉर पासिंग मैसेजेस एंड डेटा बिटवीन टू थ्रेड्स. ये हो गए 4 काम. और 5वां काम शेड्यूलिंग थ्रेड्स फॉर एग्जीक्यूशन. ओके. शेड्यूल करना मतलब सबको प्रिपेयर करना. चल भाई पहले नंबर पे ये आएगा, सेकंड नंबर पे ये, थर्ड नंबर पे ये, एंड सो ऑन. दैट्स कॉल्ड शेड्यूलिंग. ओके. सो यहाँ पर वो चीज आपको मिसिंग लग रही है. ठीक है. यहाँ पर वो चीज आपकी थ्रेड लाइब्रेरी. ठीक है. सो हु इज गोइंग टू परफॉर्म, बिकॉज ये काम हम किसी एक्सटर्नल आदमी को दे नहीं सकते, किसी के ऊपर रिलाई नहीं कर सकते, बिकॉज दीज आर द कर्नल लेवल एप्लीकेशन, kernel level process, and then their threads. Okay, so these are the important one. These are the system services. We cannot rely on any of the party. Okay, so this thing is being performed by the kernel itself. Okay, kernel खुद करता है. kernel मतलब अंदर ऊपर से आपका operating system. ठीक है. So kernel, they have kernel level threads. Okay, and they can go for the thread creation. They can go for the scheduling, and they can management. Obviously सबको manage करना है. Okay. हाँ, तो ये इतना था आपका कर्नल लेवल थ्रेड्स के बारे में. तो सिंपली the task was performed by the thread library in the user level thread, but in the kernel level thread we don't have such kind of thing. We do all those tasks is itself performed by the kernel. Okay, so ये हम लोग ने एकदम थोड़ा सा शॉर्ट इन्फॉर्मेशन मैंने निकाला था आप लोगों के लिए यूजर लेवल थ्रेड एंड कर्नल लेवल थ्रेड. Okay, some advantage I just want to put up in front of you. Let me go to the next slide. Actually, I have not mentioned those advantages, but still I will try so that will be recorded in the video. When you will refer this particular video, then you can get the things. Okay. Okay, we have still 10 minutes. Okay. So first of all, we'll write the advantage. Okay. So here we will write. So advantages of kernel level thread. Okay. So the very first advantage is that I'll just read in front of you so that you will understand. It can schedule it can schedule multiple threads from the same process on multiple process. अब आपको वर्डिंग समझ में आई? वापस एक बार पढ़ता हूं मैं, एक बार ध्यान देना क्योंकि ये बहुत इंपॉर्टेंट है. इट कैन शेड्यूल मैं लिखते भी आता हूं इसको. इट कैन शेड्यूल मल्टीपल थ्रेड्स multiple threads from the same process on multiple processor. तो we have यहाँ पर मैं ऐसा बोलता हूँ कि फॉर एग्जांपल ये मेरा है CPU 1. ओके, ये मेरा हो गया CPU 2. I can have multiple processor. Okay, so this particular thread I can schedule this particular thread to the CPU 1, this particular thread to I have given to the CPU 2, and to the CPU 3, the third processor, I have allotted this particular thread to CPU 3. So this is one of the advantage of the kernel level thread. Okay, it can schedule. Now I'm repeating the statement again. It can schedule multiple threads from the same process P1, okay, from the same process on multiple processor. Okay, so this is the one advantage we can have for it. The second advantage I have written over here is that if one thread is blocked, kernel can schedule another thread of the same process. Okay, so अगर कभी for example आपके process के अंदर चलो मैं कैसे बताता हूँ. तो ये 3 है, एक process आपका process P2 है, इसमें आपके पास में thread 1, thread 2, thread 3 है. तो if one thread is blocked, हो सकता है कि आपके सारे के सारे CPU 1 को गए हो, बट जब एक ब्लॉक हो गया है तो दूसरे वाले को हम कहीं और शेड्यूल कर सकते हैं. If one thread is blocked, kernel can schedule another thread of the same process to any other processor. ठीक है, so one and the same thing, उसको थोड़ा और इसने elaborate किया. ठीक है, so यहाँ पर मैंने ये वाले thread को assign किया था, CPU 1 को assign किया था, but it has been blocked by CPU 1. ठीक है, तो आगे के thread रन हो पाएंगे? नहीं रन हो पाएंगे. So we can execute the next thread, we can schedule the next thread to another CPU or another processor. Okay, so in this way, the one and thing, both the things are same. Okay, कुछ advantage के अलावा कुछ disadvantage भी हम लोग mention कर सकते हैं. We're not going to the deep, but we can at least mention these are the disadvantages. These are slower to create and manage because these are the kernel level thread. As we have seen, the advantage that it is faster. Okay, it is faster, and but in the kernel level thread these are slower. ठीक है, तो slower है थोड़ा सा, एक ये लिख के रखते हैं, slower to create and manage. It requires mode switch. If switching is done from one thread to another, the thread within the process. Okay, so mode switching यहाँ पर एक disadvantage है. मोड स्विचिंग अब कैसे, मैं आपको थोड़ा सा बताता हूँ. नाउ ट्राई टू अंडरस्टैंड. ठीक है, okay, as I told you that we have a process, and in that particular process we have multiple threads. Okay, so it might be possible that while execution we have allotted to this one CPU. For example, we have a CPU and we have given a task to execute all these threads to this CPU. ठीक है, so first one what it wants to say is switching. So for example अभी execution start हुआ. ठीक है, तो आपका thread 1 ने execution start किया. execution जैसे start किया, after some amount of time, okay, after completion, that is of 50% completion of a thread one. I'm talking about the thread one only. I'm not talking about the whole process. I'm not talking about the whole process. I'm just talking about the thread one. So we have started the thread one execution, but after 50% of execution, it requires something. It requires some external resource. Okay. So meanwhile it will go for the execution, or it will go for the accessing of the external resource. We can switch. We can switch from thread one to thread two. So the switching is also possible, but that switching mode is to be mentioned. Okay. तो स्विचिंग करने में जो हमको टाइम लगेगा, जो डिले आएगा, सो दैट इज कंसिडरेबल डिले, कंसिडरेबल बोल रहा हूँ मैं, दैट इज नॉट एक्सेप्टेबल डिले. तो उसको एक थोड़ा हम लोग डिसएडवांटेज पकड़ सकते हैं कि स्विचिंग इज देयर, बट यू विल इफ यू विल सी there is not a single switching in the user level thread. Okay, but in the kernel level thread we will find there is a switching between the thread, because it is possible that one thread is blocked now, या फिर it has waiting state. Now the second state in the second thread is now going for execution. Okay, so we have to switch. Your processor has to, like, we can switch from one process to another process. So in the same way, there may be a switching between one thread to another thread. Okay, or maybe it is also possible that we have another process, like we can say process number two. Okay, so we have another three threads like T1, T2, T3. Okay, so ये पहला वाला हुआ कंप्लीट, इसके बाद में ये वाले प्रोसेस का भी इसको आ सकता है काम, मतलब ये ऐसे भी स्विचिंग पॉसिबल है. ठीक है. So mode switching is there, which is one of the disadvantage, because mode switching takes the time. It gives some sort of delay, so it comes under the disadvantage. Okay, so these are few advantages and disadvantages of the kernel level threads. Okay, हाँ, ये तो नहीं आपके सिलेबस में, बट स्टिल मैं आपको खाली मेंशन करके बता देता हूँ. I've also written the user level thread and kernel level thread का difference. Okay, so just in the user level thread, so it is faster to create and manage, but the kernel level it is slower, as I told you right now only, ये slower है. So user level thread, they are faster to create and manage, but the kernel level thread, they are slower to manage and to create. Okay, implementation is done by thread library. As you know, सारे काम कौन करता है यूजर लेवल थ्रेड के अंदर? एक बार मैं लिखे लेता हूँ, ये मेंशन कर लिए, ये आपका यूजर लेवल थ्रेड. ओके, दिस इज कर्नल लेवल थ्रेड. ओके, ट्राई टू अंडरस्टैंड. दीज आर फास्टर. थोड़ा फास्ट फास्ट लिखते आता हूँ मैं, आप लोगों को कम से कम ये रिकॉर्डिंग में रहेगा तो याद रहेगा. Even this question is not there, but still if someone asks, then you can at least answer few of the points. Okay, this is faster to create and manage, this is slower to create and manage. Second point, implementation is done by thread library. Okay, library implementation is done by thread library, and your OS support creation of kernel thread. Okay, so यहाँ पर कौन करता है? आपका कर्नल करता है. तो कर्नल इनडायरेक्टली कौन करता है? मतलब आपका ऑपरेटिंग सिस्टम करता है. ठीक है. So your third point, they are generic and can run on any operating system. They are generic and can run on any operating system. Can run on any operating system. Okay, but then in this way, they are not generic and cannot run on operating system, because these are the kernel services, these are the kernel threads, and they are platform specific, so they cannot run on any machine. So they are not generic. So not generic. Okay, so it cannot run on, ये आगे इसके consequently आ जाएंगे. ठीक है. Number 4, the last point we can mention, many to one mapping is possible. Many to one, यहाँ पर one to one mapping possible. ये एक important है यहाँ पर, many to one mapping is possible. Mapping is possible. डायग्राम में देखे ना हम लोगों ने, आपका आपके सारे के सारे, कैसा एग्जांपल यहाँ बता देता हूँ. ये आपका एक थ्रेड, दो थ्रेड, तीन थ्रेड. यहाँ पर क्या था? आपका थ्रेड लाइब्रेरी, सबका सब क्या मैनेज हो रहा है? यहाँ पर मैनेज हो रहा है. और यहाँ पर हमारा क्या था? CPU था, अगर याद होगा अगर आप लोग को. ठीक है. सो मैनी टू वन मैपिंग इज पॉसिबल इन द यूजर लेवल थ्रेड. इन कर्नल लेवल थ्रेड क्या था हमारा? यूजर लेवल ये हमारा कर्नल स्पेस में हमारे कर्नल थ्रेड, सो हमारे कर्नल लेवल। सो या मैपिंग ये क्या हो गई, मैनी टू मैनी मैपिंग। सो वी कैन से दिस इज मैनी टू मैनी मैपिंग। Okay, so these are the 4 points I've mentioned just for your reference. Okay, just to understand the difference between the user level thread and the kernel level thread. This question is not still, this topic is not there in your syllabus, but still you know. Okay, so I hope this is enough for today, and we can start with the next topic, that is scheduling algorithm, scheduling of algorithm. Okay, from the next lecture we can start that topic. Okay, okay, nobody is responding. समझ में आया आज का लेक्चर? कोई कुछ बोलते ही नहीं। I'm just discarding the things because it has already been recorded by the recording part. ये भी हमारे आज हम लोग ने इसके ऊपर कुछ काम नहीं किया. Let me just stop the recording first.